Welcome to our guide on implementing one-to-one relationships in database design. Understanding how to correctly enforce these relationships is crucial for maintaining data integrity and clarity in your schema. A classic example of a one-to-one relationship is between a passport and a passenger. In database implementation, a one-to-one relationship becomes a foreign key. This key can reside in either of the two tables. The key decision is determining which table will host the foreign key. Best practice suggests placing the foreign key in the table expected to have fewer rows. This technique helps minimize the number of null values in your database, keeping it clean and efficient. The foreign key must reference the primary key of the related table, and critically, the foreign key column itself must be unique. In SQL, this is achieved by specifying the foreign key constraint, referencing the opposite table's primary key. To enforce the one-to-one nature, apply the unique constraint on the foreign key column to ensure no duplicates exist. If the entity on the opposite side of the relationship is required to exist, you need to enforce a rule. This is done by applying the not null constraint to the foreign key column, guaranteeing a value must always be present. Using not null ensures that an entity can only be created if the corresponding required entity is also linked. Naming conventions help keep your schema readable. The foreign key is typically named after the referenced primary key, such as passenger ID. An optional prefix, often derived from the relationship name like passport passenger ID, can be added for enhanced clarity. Let's look at the full SQL statement to implement the passport passenger one-to-one relationship. Here is the SQL to create table passport with the necessary primary key, unique, and foreign key constraints. This implementation ensures that each passport is uniquely linked to exactly one passenger, rigorously enforcing the one-to-one structure. To summarize the core principles for one-to-one relationship implementation. Remember, correctly implementing these relationships ensures each entity is paired uniquely, which is essential for data integrity. By applying these steps, you maintain consistency and clarity in your entire database design. Thank you for watching.
Relationships. So in this case, in this activity, as you can see, we have each airport has at most one address. Each airport has at most one address. Each address has at most one airport. Then every airport has an address, but some addresses are for people, not airports. So the airport has fewer rows. So every airport has an address, but some addresses are for people, not airports. So the airport has fewer rows. The foreign key goes in the table with fewer rows, right? Airport address ID. Then in this case, the prefix is derived from the table name instead of the relationship name. Okay? And the address entity is required, so the foreign key is also required. The address entity is required, so the foreign key is also required. The airport entity is singular, so the foreign key is unique. Address key entity is singular, so the foreign key is unique. So now that we've gone through this flow chart to understand one-on-one relationships, let's get to work on this activity so that we test our understanding. So some passengers provide a personal contact to the airline in case of an emergency. So you have passengers with a required key and a unique key, then passenger name. So passenger contact have the contact number with a required key and unique key, then contact name and contact phone number. So the primary key of the passenger table is passenger key. The primary key of the passenger contact table is contact number. So in which table is the foreign key placed? It's placed in the passenger contact. So if you chose passenger, why were you wrong? Because not all passengers provide a contact. So the passenger contact table has fewer rows. The foreign key is placed in the table with the fewest rows. If you chose cannot be determined from the diagram, this is why you're wrong. The foreign key is usually placed in the table with fewer rows, which can be determined from the minimum cardinality of the relationship. So the right answer is passenger contact because all contacts are provided by a passenger, but not all passengers provide a contact. So passenger contact has fewer roles. So for one-man relationship, the foreign key is usually placed in the table with fewer roles. So what is the name of the new foreign key? Should be contact number? No, because the foreign key in contact number refers to the passenger. The foreign key name usually includes the full name of the reference primary key. So is it the passenger key? Yes, because usually foreign key name includes the name of the reference primary key. In some cases, the foreign key has a prefix derived from the relationship name, X provider, passenger key. So why is it not passenger? Because the foreign key name usually includes the full name of the reference primary key. So this is passenger key. So is the foreign column required? So when we put cannot be determined, it is wrong because minimum cardinality of a passenger is specified in the diagram. So the correct answer can be determined. Is there a minimum cardinality in the diagram? Yes, you can see it. So no is incorrect because if the entity on the opposite side of a relationship is optional, the foreign key column is optional. However, passenger is required in the passenger provides passenger contact. So the correct answer is yes, because if the entity of the opposite side of the relationship is required, the foreign key is also required. Passenger is required in passenger provides passenger contact. So the foreign key column is also required.